We've all worked with probability. We've all worked through this stuff before. We've seen it. We've tried it. We did the whole idea of flip a card over and Shimke. What is it?
6 of spades. 3 of spades.
So what you're looking at when you're dealing with probability is always going to be of some outcome. You'll see it written with P parentheses. In the parentheses is what you want. We were guessing probability. What'd you say it was going to be? It's not the Queen of Hearts. It wasn't today, correct. You were looking at the probability of Queen of Hearts. Well, in a deck of cards, how many, if you're not cheating, how many of them are the Queen of Hearts? One. So probability is found by favorable outcome over total possible outcomes. So probability of the Queen of Hearts was there's 1 out of 52. So the probability is always going to be less than 1, which means probabilities have a range to them. Probabilities are always going to be less than 1 or equal to 1 or greater than and equal to 0. Probability of something happening well, yeah, something's going to happen there apparently, right? So the probability that something is going to occur is always going to be between 0 and 1. Yes, ma'am?
What? It says total
Possible. If your probability is 0, what does that mean?
Never happens.
Not gonna happen. If probability equals 0, not gonna happen. If the probability equals 1,
It will happen.
It's definitely gonna.
it's gonna happen. For example, I don't know.
You spell it with a U.
Oh, Mr. Murphy.
The probability of homework is 1.
Wouldn't change it real quick.
But I don't want to play with those chances.
Over 1,000.
I'm gonna have to go again.
It's still going to be 1. So that's what's nice about probability then, is that you know that if your answer is greater than 1, you done goofed. If your answer is negative, you really done goofed. All right? Jeez. So what we're looking at here is favorable over possible. And I know that you guys have all done that. For example, yes, sir?
So like when people say horse races and stuff, it's like 50 to 1 odds.
Those are different. Odds are a little bit different than probability.
Oh, they are.
Odds are more of a, it's more of a, there's more factors thrown into it. When I'm looking at pure probability.
So it's just the straight chance.
Correct. Correct. I'm looking, and you see that a lot, and that's kind of what shows up on my Powerball. It tells me odds, which is very close to, in this case, their odds is really kind of is probability, but when somebody else asks about like the wagering idea of like betting on sporting events, it's still a heads or tail thing. You're either win or you're going to lose. But there are other things that you can factor into it, like you're saying with horse racing. That's where odds come in, because then it pays different for less, or the lower the odds, the higher the payout, versus the better the odds, the less payout.
Right.
So you can rank within probability. We're looking at just pure probability. Anything you're saying? Mr. Soto, you got something?
I did, but I forgot.
All right. So when I'm looking at this one here, you'll see that there are types of probabilities here. pure probability, yeah.
Okay, here's the thing that I was gonna ask. Isn't the probability, the thing I don't understand about probability is, for example, we say there's a 1 in 50 chance that the card that we're gonna pull up is going to be like a queen card.
Right.
Sam said. But isn't it already kind of predetermined that the card that you were gonna pull up, as long as you push from the top of the deck anyway, was gonna be a 3 of spades, regardless of what we said? So isn't the odds always like 100% more a 3 of spades?
No, you're trying to get into something way too much to worry about. All I'm looking at is just pure pick a card. Blind pick out of a deck of cards, what's the probability you're going to pick the Queen of Hearts? It doesn't matter that it's shuffled or not shuffled. If I didn't stack the deck, if you will, against you, if it's just a natural draw, you know, an unloaded event, you're just looking at, there's 1 in 52 chance of picking it right. Same idea as a die. If you roll a die, how many sides are on a regular die? 6. What's the probability of rolling a 3? 1 out of 6. You're not weighting anything. You're not trying to say that something's weighted more to one side or the other. Okay? You don't need to get into that. That's something that what you're looking at, I don't think even occurs. Don't worry about it. Back to this one real quick here. When I'm talking about, remember when we first looked at these things, we're picking numbers 1 through 55, so the probability that I'm going to pick one of the numbers right is 1 out of 55. Over the course of 57 or 47,000 years, my experimental probability, process of doing the same experiment over and over again, is showing that I'm only getting it about 1 in 58 times. Probability of getting the blue and the red should be about 1 in 111. My frequency that it's occurring is a little bit better. I am beating the natural probability with my experiment. And I think some of you guys have done some of these natural selection testing things with experimentals like this before. So you've seen probabilities of something occurring and outside of the experiment it occurs better. It happens. We look at it in terms of general population stuff. So we get into a little bit more of independent, dependent things, which you'll probably like because that's how your brain goes sometimes. Next week, okay? So if I go back and I'm looking at just rolling a die, what was the probability of rolling a 4?
1 in 6.
1 in 6. What's the probability of rolling an even number?
1 in 3. 3 in 6. 1 in 2.
Okay, so I was wondering where you're going,
1
like,
in 3.
the probability of rolling an even,
So it's 3.
3 out of 6, so it's 1/2. Same thing here is that you always simplify your fractions. If you write it as a fraction or a decimal, it's not a big deal. What's the probability if I roll a die and it's going to be less than 7? 100%. It's going to happen. And we're not taking into account that for Cooper asks, no, what if it lands on its side and it doesn't land on a number?
You sound like,
Spicoli.
or what's
A little bit. Too late.
Chris Farley. Yeah, you sound like Chris Farley.
In a van down by a river.
He sounds like Chris Farley.
For example, when I talk about this whole experimental probability, sometimes you're looking at a data set. Don't write this down. And I know you guys have seen something like this before. If I'm just looking at a data set with counting people, and I want to say what's the probability that I pick a person at random and they're going to be at least 45 years old. Well, at least 45 means that, is that the highest they can be or the lowest they can be?
Highest.
Lowest.
Lowest. So, well, you had a 50-50 chance and obviously you blew it. So, don't quit your day job.
I don't have a day job.
Get one.
Get one and don't quit it.
Yes. So if I'm looking at this table then, what 2 values do I have to add up to account for people that are at least 45?
60,000.
No.
Yes, I can. These are just the range of people here, man. These are just the ranges. These are the actual numbers. So I'd add those 2 together, and then what would I divide it by?
All of them.
I'm not finding the average.
All of them together.
I would divide it by all of them together, okay? So I would take these numbers, I would take those numbers and divide it by all of those numbers, and that would give me some percent or a fraction or a decimal.
Oh, that actually doesn't even mind. It's sort of like a circle with 11
I know you guys have seen this. The other stuff comes into what you forgot. Geometric probability. Geometric probability was the probability of landing in a shaded region. For example, you guys did this last year, I know. Geometric probability is your shaded, the area you want. Oops. Over total, the area total. A lot of times you'll see circles and squares and things like that. I'm going to go out on a limb and assume that you remember how to find the area of a circle.
Pi r squared. 2 pi r.
He said pi r circle.
No, I was gonna say squared.
You would have been right.
Yeah. He said pi r circle.
I was
So,
gonna say pi r squared. I was gonna say squared.
and I thought pies were round.
They are.
Not a slice of
That's a second. It's a seconder. So, what's the probability that we're going to get a bullseye here? What's the area of the bullseye?
It's
5.
pretty large.
9 pi.
What's the area of the bullseye?
9 pi.
It's 9 pi. What's the area of the total shape?
11.
Wait, no.
6, 7,
144 pi.
Is that 12?
I'm so.
What?
144.
Do you have an apple?
give him some tight so they can be rapid.
What? Can I?
Me rocket now?
Yeah,
You scared me a lot.
try to flip it.
Okay, yeah, you have to put one of those
Delete
options
it.
now.
Delete it.
Yeah, you could.
Yeah, cool.
Nothing but kind again.
What's wrong, Shifty? You worried?
She's jealous.
No, I'm not. Shoot it the wrong way.
You have the bone back. What was that?
Music.
How was someone there from?
Everybody's so scared.
You know, I'm pretty sure this is live. How are you doing? No, so close. Yeah, close. That's not even part of the probability.
Crossbowing is a little bit easier.
Yeah.
Whatever. So let's just say let's just say for argument's sake, the bullseye was 9 pi over 144 pi. I will say one thing when you're using your calculators, if you're just going to type 9 pi divided by 144 pi, you're going to be wrong. Make sure you use a fraction bar because calculator doesn't know. It'll take the 9 pi divided by 144 and then it'll just multiply it by pi. Use the fraction bar. What was it again? It was like what, 1/6? 1/16? 1/16? So let's just say I was super awesome and I got the bullseye because I really want to try to get the world record. Are you trying to mouth off for me?
Hit her.
Wait, why are you
Oh, look at that stance.
We're feeling like 2 steps closer.
You got the music? Isn't there's something on the other side? Is it just like that on both sides, or are you, like look on the other side? There's like a whole. It looks like
Yeah, it's for lefties and righties. It's ambidextrous.
Oh, I thought you were using the wrong side.
Ambidextrous.
I can't stand that title.
I can't stand
Sit it, no. Mr.
You know, I will say my $2.99 bow and arrow from Walmart. I did, but it lasted me a couple of years.
Mr. Murphy.
No.
Have you
Have you ever actually made a statement with that?
Not yet. Or do you want to say accident?
Alright, now quick, think of the probability that you get that.
Oh, that's pretty easy because you could figure that out because if I want to get just that circle, I'd have to find the area of this whole circle and then subtract out the inner part.
Alright, then let's do it.
All right, well, what's the radius of this third rung circle? 6. So the area would be 36 pi, but I have to subtract out the radius of 4. So what's the area of this rung?
20 pi.
It'd be 20 pi.
20 pi.
So if I want to just get the probability of just getting that interior rung,
20 over.
it'd be 20 over 144. 10 over 72, so it'd be something like that. Pi 36.
Yeah, I got that.
Isn't that better than 1/16? Still can't do it.
What's the probability of missing?
1.
Oh, so sorry.
You're wrong.
Oh well. So, but let's just say for instance, I did get it a bullseye.
You're wrong.
Let me saw it.
Is this play music when you do that?
Yes. And this is there we go. The
Simpsons.
yeah, that's what I This is not sure if serious. That's what I'm afraid of.
What's the
Anyway,
sign?
the one thing that's different with this board versus the old ones, and in case you guys haven't known or noticed, math really hasn't changed a whole lot in a couple years. So geometric probability is still, geometric probability, but smart boards have changed. For example, if you make a fist and you touch the meat of your thumb here, see how you can press into it a little bit? That's about, yeah, and that's how it was with the older style smart boards, is that they had pressure plate behind it. So that's how it knew where you were at. The downfall of that was that it could rip, it could tear. The newer boards are solid. What's that?
There's like soft spots.
Yeah.
Yeah.
At the old school, that's what we had at the old one. The newer ones, these have 4 cameras in the corners, and they triangulate for distances of where you're at. They just don't pick up the high velocity arrow that I have. So I'm almost thinking I might have to get a Nerf gun.
Let's do it.
Mr. Murphy.
I'll
was
bring
it
you one. I got like
that-
the.
Was it you said that when you went to that tech expo that they had that projector where it was like all in one, so you could just project it onto like any old wall or board or something and it would still function just like
There is one like that. I think you can make one with like a Wii. I don't know. I'm not that much of a nerd. Oh, sorry, I was trying to get the board.
I spoke to you.
No.
I called it.
I'm trying to, I got the board earlier today. Sorry.
I came to your class and you killed me.
I was trying to kill you. I really did. Only your eyes. You got really cool.
I think I just witnessed my teacher trying to kill the students.
I guess the promise for you is we'll talk more about this tomorrow. This is 12-3. I just forgot what numbers they were. It starts over on 719. I want you to go 12 through 34. These are really fast.
Every other even.
These are, I mean, most of them are, what's the probability of rolling a 3 or a 4?
6. 25.
Yeah. So a lot of them are like that. Okay. No, it's about the break. There's not much elasticity left in my awesomeness.
Dude, I can fix it.
Hey, you? I don't know if I'm allowed. I'm fighting pushing my luck with my bow and arrow here. I know it's a weapon. What homework do we have?
I don't know if I did yeah, because he said everyone did really bad on it, like they forgot you guys and stuff like
Yeah. No, it was my turn.
Yeah, I'd be so upset with that.
I didn't know
Yeah, if you're not first, you're last, right? Have a good one, guys. We'll see you tomorrow.
Oh, it's not Friday.
I know. These days would be better if it was a Friday.
Yes.
So.